Hey guys, welcome back to Unit 8B. This is going to be day 2. We're going to be solving trigonometric equations. If you like algebra, if you've enjoyed solving, you're going to enjoy this piece of the unit. However, there's going to be different types of equations that you're going to have to see. So in the helpful hints, it says to try factoring, the square root method, or using Pythagorean identities. Always think back to how you solved similar equations in Algebra 2 when x was a variable. All right, so you're going to be doing a lot of the same practices, and then we will continue using the unit circle as we do this. So we're just going to go ahead and jump into the first one. We are going to use the square root method. On this first one. So just like any algebra equation, sine x is going to be x. So if we are looking at sine x as if it were x, this is basically the same as saying 2x squared is equal to 1. So the first thing we would do is divide by 2. All right, then we're left with sine squared x is equal to 1/2. And again, this is the same as saying x squared is equal to 1/2. So we would square root and square root again. And that would leave us with just sine x is equal to the square root of 1 over the square root of 2. Now, the one thing you have to remember when you're doing square root is that when you square root, your answer is now a plus or a minus, because the square root of a number can be positive or negative. All right, the square root of 1 is always just going to be 1. So this just leaves us with 1 over the square root of 2, which we can't have. We can't have that radical in the denominator. So we're going to multiply the bottom by the radical and the top. And this is going to look very familiar to you. You're left with the square root of 2 over 2. And this is positive or negative. And this is equal to sine x. So what we do with this information is, where is sine x equal to the square root of 2 over 2? Where on the unit circle? All right, so once we look at the unit circle, we will find, and that again, that has to be positive or negative. So we should have 4 different possibilities here because of that. X could be pi over 4, 3 pi over 4, 7 pi over 6, or 7 pi over 4. So we're taking this information that we solved for and we're going to the unit circle and finding, well, what could be the x value? X is equal to somewhere where sine is equal to positive or negative square root of 2 over 2. So I will go find where sine is positive or negative square root of 2 over 2. Five pi over 4, 7 pi over 4. All right, and these are your possible values for x. Okay, let's move on to the next one. So in this one, we're going to end up using the greatest common factor method. That's when you pull something out, and that's going to give us 2 different options. So, because we have 2 cosine squared x minus square root of 3 times cosine x, and that's equal to 0. So we're going to pull out the cosine x. And over here, I should still have 2 cosine x because this is cosine squared minus square root of 3 is equal to 0. So now we've separated it into 2 possible x values. So the first one is this one here, cosine x. We'll just set that equal to 0. We will take this chunk that's in parentheses and solve it as well. So we would have 2 cosine x minus the square root of 3 equals 0. I'm going to go ahead and move that square root of 3 over. Divide by 2. So cosine x is equal to the square root of 3 over 2. Or cosine is equal to 0. So where on the unit circle is cosine equal to 0 or the square root of 3 over 2? And we will find those. So let's start with 0. Where's cosine equal to 0? We've got pi over 2 and 3 pi over 2. And then we need to find where cosine is equal to the square root of 3 over 2. So we have pi over 6 and 11 pi over 6. And those are our possible values of x. All right, we will move on to the next one. Okay, when you see one like this, we have cosine and sine involved. The only way that we can solve this is if we have everything in the same trig identity. It all has to be one function, so that's the first thing. Needs to be one function. So we either have to find a way to convert sine squared x to cosine, or both of these cosines to sine. And honestly, the easiest thing is going to be converting the sine squared x. We're going to use our Pythagorean identities for that. We'll have those. I have those underneath to look at. So it all needs to be one function. It must equal 0. All right, so whatever we get here, whatever we convert it to, we're going to have to move it all over and set it equal to 0. And then eventually we'll probably have to do some factoring. So first things first is let's figure out what we're going to change sine squared x to. Sine squared x is going to be equal to 1 minus cosine squared x. So that's what we're going to end up changing it to. So I'm going to rewrite it as cosine squared x plus cosine x is equal to 1 minus cosine squared x. Now, again, we're going to have to move everything over. So let's go ahead and add the cosine squared x, add cosine squared x. That gives us 2 cosine squared x plus cosine x, and I'll go ahead and move this 1 over as well, minus 1, and that is equal to 0. All right, so here we can factor. If I were going to factor this, you're probably thinking, how? Well, again, if cosine x is x, this is the same thing as factoring 2x squared plus x minus 1. Because this is cosine squared, right? So we have x squared, 2 in the front, plus cosine x, which is just x, and then minus 1. So we would factor that. I'm going to go ahead and write it. We've got 2 cosine x minus 1. And again, if you are able to change it to this and that makes it easier for you to factor, you're more than welcome to do that. If you need any help with this, please reach out. I'll be happy to go through a couple of these with you and get you better at converting so that you can factor. And then we'll have cosine x plus 1, because this would end up being 2x minus 1, x plus 1, and that's where we get our numbers from. All right, so we will end up doing these separately. So we have 2 cosine x minus 1 is equal to 0, and cosine x plus 1 is equal to 0. So we would have 2 cosine x is equal to 1. Cosine x is equal to negative 1. Divide by 2. Cosine x is equal to 1/2. All right, so we're looking for where cosine x is equal to 1/2, and then where cosine x is equal to negative 1. So those x values, let's start with the 1/2. We have pi over 3. And I think just 5 pi over 3. And then where cosine is negative 1, there's only one position there, and that's going to be pi. And those are our values of x. All right, we got a couple more problems we're going to go through. Feel free to pause at any time and try to work it yourself, and then continue on with the video to double check that you're doing it correctly. So again, we have cosine and sine. We're going to have to change to one function. All right, so let's see. There's really no way that I can just change sine to cosine, or cosine to sine for that matter, unless it were squared, because those are the Pythagorean identities. So what I'm going to do is, I do know that sine over cosine or cosine over sine, it could be tangent or cotangent. So we're going to find a way to do that. So we're going to have sine x is equal to the square root of 3. Whoops, that looked really weird. And yes, we will end up putting this back. But just follow along with me. So we're actually going to divide by cosine. So we end up with sine over cosine, which is equal to tangent is equal to the square root of 3. So we have to find where does tangent of x equal to the square root of 3. All right, and then hopefully you have your tangent chart. If not, you can figure it out as we go. We know it's not going to be the fourths. Those are -1, +1. It would either have to be pi over 6 or pi over 3. Pi over 6 gives us the square root of 3 over 3. These will present 1 as the tangent, and this is the square root of 3. And you can write those every time you go. This is negative square root of 3. If that helps you to know these tangents, go ahead and write them on your unit circle. That's going to make things so much easier for you as we go. So where tangent is equal to the square root of 3 over 3 is going to be at pi over 3. And then where the negative is, down here, 4 pi over 3. All right, we've got 2 more examples that we're going to work. Okay, so we have 2 sine squared x minus sine x equals 1. We're going to end up factoring this one again. And if you want to pause so you can try to do it on your own, do that. Move the 1 over. We've got 2 sine squared x minus sine x minus 1 is equal to 0. All right, this is the same as saying 2x squared minus x minus 1. So once we do that, we'll have 2 sine x plus 1 sine x minus 1 is equal to 0, because when we factor this, we'd get 2x plus 1 and then x minus 1. Okay, and we will solve them separately. We have 2 sine x plus 1 equals 0, so we have 2 sine x is equal to -1, divide by 2. Divide by 2, sine x is equal to -1 over 2. All right, and then we have sine x minus 1 is equal to 0, so where sine x is equal to 1. All right, so our x's are where sine x is equal to -1 over 2 or +1. All right, so where sine x is equal to -1, we've got 7 pi over 6. And then we have, I think that's it. I feel like I'm missing one. Aha, 11 pi over 6. There should typically be at least 2 of everything, unless it's an axis. Sometimes there's just 1. So most of the time you should have at least 2 answers for every sine or cosine that you're finding. And then we have where sine is 1. And that will be pi over 2. All right, our last problem. So the only way, because we can't just divide by sine here to get cosine over sine and change that to cotangent, or divide by cosine here, because this one isn't attached. If it were -1 times sine of x, we could end up dividing and getting a quotient identity. But because they're not attached like that, we can't. So the only way we can get rid of it, and every once in a while you'll see this, is we've got to square both sides. Okay, so we'll have cosine squared x is equal to sine x minus 1, sine x minus 1. All right, we're going to go ahead and factor all of that out. So again, we'll have cosine squared x is equal to sine squared x minus sine x minus sine x plus 1. So we will have sine squared x minus 2 sine x plus 1 is equal to cosine squared x. Now, again, we're still going to have to change to one identity instead of changing all of this sign, because that would be really time consuming. We're just going to change the cosine squared x, because we can change cosine squared x. Cosine squared x is the same as 1 minus sine squared x. So we have 1 minus sine squared x is equal to sine squared x minus 2 sine x plus 1. And we're going to be able to get rid of some things here. So let's move everything to one side, set it equal to 0. Add sine squared x plus sine squared x minus 1 minus 1. So we have 0 is equal to 2 sine squared x minus 2 sine x, and that's it. And now we can do our greatest common factor. We're going to pull out 2 sine x. Can't forget the 2 because they both have a 2 here. All right, so we'll pull out 2 sine x, and it's equal to sine x minus 1. All right, so we have 2 sine x is equal to 0, and sine x minus 1 is equal to 0. And so this will obviously just become sine x is equal to 0, and sine x is equal to 1. All right, so where does sine x equal 0 and 1? We will have sine x is equal to 0 at 0 pi and then we will have pi, and then where sine x is equal to 1, and that's just one location. That's going to be pi over 2. But one thing we've got to do here is check the solutions. So we're saying that if x is 0 pi, that the cosine x is equal to the sine x minus 1. So at 0 pi, cosine of 0 pi is 1. And they're saying that 1 is equal to 0 minus 1. That means that 1 is equal to -1. That is false, therefore not a solution. All right, we have where x is equal to pi. That means cosine at pi is -1 is equal to sine pi, which is 0 minus 1, And that means that -1 is equal to -1, and that is true. And then cosine is equal to pi over 2. Cosine at pi over 2 is 0, is equal to sine, which is 1 minus 1. That means that 0 is equal to 0. And those are true. So this is how you can check to make sure that your solutions actually work. All right, and that is 8.2.